Thanks very much, Steve. So I'm a Deputy Director at Nectar and the National E-Research Collaboration Tools and Resources that run the National Research Cloud. Now there, you may have seen already, there's a number of people from Nectar here. They have Nectar T-shirts on, some of them. The lucky ones have the special Nectar T-shirts. And Glenn Maloney, the Director of Nectar, is up the front. So feel free to come and talk to any of us if you have any questions about this stuff. So just what I wanted to mostly talk about today was around the issues of federation and interoperability in clouds in general and our research cloud in particular, but I'll give you a bit of a background initially around Nectar. So Nectar is funded by the federal government as a national research project, a research infrastructure project. It was originally funded through the Education Infrastructure Fund and then through the National Collaborative Research Infrastructure Strategy, or NCRIS. Starting in 2010. So basically the idea was to provide computing infrastructure, storage infrastructure through a cloud-based model to help enable research collaboration across institutional boundaries. So really at a national scale, not just a lot of local institutions to do what they want to do internally. So it helps the research community to store, access, analyse data and share it across their institutional boundaries. There's two components to Nectar, one of which, the part I'm responsible for, is the Nectar Research Cloud. It's essentially the infrastructure and services. And the other part is the Virtual Laboratories program, which is essentially around developing applications for researchers and particularly research domains and disciplines that can run on the cloud. So, why do this? So the idea is, again, we're trying to help. The whole point of NCRIS in general, national research infrastructure, is to help enable both national and international collaboration in research, to provide the tools that researchers need, and obviously, IT computing is a huge part of research these days. So we're trying to make these things easier for people to use, make it easier for them to do their modelling, data storage, data analysis online in collaboration with their collaborators that could be at any institution. So just briefly, Nectar runs a number of virtual laboratories across many different disciplines, trying to develop online tools, portals, etc., to make it easier for people to put data online, to analyse it, to share it across many, everything from the humanities to astronomy. So this project, for example, the chief investigator was a Nobel Prize-winning astronomer, and it's around data from very large, expensive instruments. So this was a kind of no-brainer to fund that one. But there's a very interesting mix of virtual laboratories there. You can see all of them are in partnerships with a number of different organisations. All of them support very large numbers of researchers, both nationally and internationally. So those are the kind of things we want to support. And here's an example of things that aren't virtual laboratories that Nectar supports. There are national scale cooperative research centres, centres of excellence around stem cell analysis, analysing plant energy biology, cancer therapies. So a lot of these large national collaborative groups are supported on the Nectar Cloud. So perhaps one of the more interesting things about the Nectar Cloud is it is a federation. So it's not like a commercial cloud where one organisation stands up a cloud and offers these services. It's actually a federation across 8 very different organisations around the country, as you see there, spanning a national scale. And that was really a world first. So we started with OpenStack very early on. Back in 2011, when it was difficult choice, I think, to figure out what cloud platform we'd go with, and now obviously it's turned out to be a very good choice. So the project started in 2010. We kicked off by having a workshop to basically decide what we're going to do, what sort of cloud middleware would we use, and OpenStack was chosen. There was a proof of concept stood up in 2011. I think Sam Morrison, one of the lead devs, was saying they used the Cactus implementation. So as you know, the OpenStack releases go A, B, C, D, etc. So we're up to N or O these days. So it was a very early deployment of OpenStack back then. University of Melbourne had the initial deployment, and that ran for a couple of years, and then as you can see over time we've added more and more of the 8 nodes into the cloud to get to where we are at the moment. And it's been hugely successful. So you can see the number of users here has been increasing, I think around 40% a year, fairly consistently since the cloud first went into production in the beginning of 2012. And the number of resources, the number of cores available have been gradually growing. The different colours here are the different institutions that have, the different partners that have come on at different times and added to the resource. In fact, Nectar only funded a little over 30,000 cores, but we're up around 40,000 now, and that's basically institutions putting their own money into adding resources to the cloud because they see the benefit. You can also see across the right here, there's a bunch of standard sort of codes for different research areas that the Australian Research Council provides. And you can see we split across pretty much all of the high level, I think there's 20 odd high level research codes for different disciplines, and we have researchers from all of those areas using the cloud. Some of the larger users are in computing sciences and biological sciences and genomics and so on, but there's a very good mix. So we have this federation model. So the way we've done this is OpenStack provides this mechanism called cells. So basically each of these sites have one or more data centres with the computing infrastructure in it, and they're made available as cells. So one could have private cells. If I've put my own, bought the kit myself, I can just have my own local researchers use it. If it's part of the national federation, essentially a user can ask for a particular cell. There may be some good reason why they want to run locally. Their data is stored there or whatever. They want to have local access to that data. Or maybe they don't care. Just fire me up a VM anywhere where there's available resource. So basically they can request a particular site, or they can just say, run it anywhere, I don't care, and a scheduler will go and look and see where there's resource available to fit what they want. So the way we do this, we have a central group of people who run the sort of central core services, like the dashboard, so people see a single national interface to the federation. They authenticate using a central keystone authentication system, and the way we built that is to leverage off the Australian Access Federation, which is an identity federation that all of the universities and many of the other research institutions in Australia support. But that basically means people can log in with their institutional credentials. We don't essentially need to set up a Nectar account or give them a special Nectar account. They just log in with their institutional username and password, and they automatically have a Nectar account, and away they go. So this has been extremely useful for driving uptake. There's sort of low hurdles for people to just get on and try it out. And in fact, we allow anyone who logs in to have a small amount of resource, a couple of cores for a few months just to try it out, see if it meets their needs, and if it does, they can ask for a bigger allocation requirement. So that really has driven that huge uptake in usage that we showed a minute ago. We have an image repository, so a number of images, virtual machine images that people can use. And then we have the sort of federated services. So we run an object store, Swift, so essentially almost all of the nodes run their own infrastructure supports that Swift object store, and it's federated. So it looks like a single store, but it's replicated across a number of institutions. And then, of course, each of the partners run their own local compute and volume storage infrastructure as well. And we also have a distributed user support mechanism with help desk, user guides, documentations, and so on that all the partners contribute to. We've also been rolling out sort of some of the higher level services that people have been interested in. Some of these are already up and running. Some of these are works in progress or things that we're aiming to do in the near future. So basically we have both nationally and locally funded cloud resources and allocations. We have a national resource allocation, but people can also provide local allocations for some of the resources. and we're really aiming to provide, here's some national standards on how a cloud that you can contribute to, but local customisations are fine. So we do have a number of groups doing GPUs, custom flavours, etc. on some of their local resources, which is fine. So that meets their specific local needs. And we have a number of standard virtual machine images that Nectar supports and provides that the user community can use, but we get contributions from the community. Here's a virtual machine image that has some of the software and tools that my research community is interested in. They can be made available and shared for other people to use. So essentially the way we have it, we have a group as a set of core services, a core group that's funded through Nectar to basically keep the central services alive. We have at each partner node, they have their own operators to keep their local cell running, and we have our distributed help desk as well. So because it's distributed and federated, it's not a single organisation, it is work to glue it all together. So we have 6 monthly tech and ops workshops. We had one the last couple of days here in Melbourne, so a number of the people who'll be here went to those workshops to talk about what we're doing, what the pain points are, what should we be doing next, make some decisions around that. We have, and then of course we have regular online meetings with the groups that help run the cloud, do the user support and so on. As well as the higher level, sort of management level meetings that we have with the directors of all the partners. So, collaboration is great, but there are challenges. There's overheads to collaborating in a federated entity. All the organisations are quite different. They have their own different view of the world, different business drivers, and so on. So it is a challenge to keep everyone in the same path. We provide contracts that specify certain things they have to do as part of the funding we give to them. Operation level agreements as being part of the federation, but essentially it's we just have to make it worthwhile for people to put their own resources and effort into being part of this national collaborative effort rather than just going off and doing their own thing, which some people might think might be easier for them to do. Now the other thing we've done is we support over 50 research institutions on the cloud. Dealing with those directly would be challenging in terms of the scale for what's essentially a fairly small central group that manages the Nectar Cloud. So basically we have this hierarchical model. Those 8 nodes that are the partners that run the cells that we're talking about, they are essentially have the universities, the medical research institutes, etc., as their partners. So we have this sort of hierarchical model that helps us with scaling things out much better. I'm getting a bit late here, so I'll skip over some of these things. There are issues of how do we manage the costs for all this. So at the moment we have a model where the end users, the researchers, don't pay for usage directly. It's their institutions and Nectar and the federal government that cover the cost of these things. So that's a good thing that researchers can go and use this resource essentially at no cost, but it does mean there are problems with that where, if you're using Amazon, you have to be very careful about your usage because you're paying for it. Whereas here we have to. The concern is people don't just waste the cycles because they don't have to pay for it. So there are pros and cons around that. As I said, the Australian Access Federation is fantastic. So one of the things we're working on now in terms of, we really want to drive this out to be more interoperable internationally as well. So we've been working with New Zealand institutions who are very keen to be to run their own cloud locally and eventually to provide a similar thing in New Zealand to what Nectar provides in Australia. So one of the good things is they have something similar to the Australian Access Federation, a national identity federation that we have hooked into our cloud to allow people to log into. And there's similar initiatives internationally to have an international SAML federation, which again would make it easier to get international collaborators of Australian researchers on board, logged in, using the cloud as part of their project allocation. So as I said, Nectar's kind of pioneered the way here, but now there are many efforts overseas that are similar, federated research clouds. I went to the OpenStack Summit in Boston. It was interesting as a presentation by CERN. I thought we were doing great to have our 40,000 core large-scale cloud. Someone from CERN gave a presentation where their spare capacity was 40,000 cores. So their cloud is honing in on 300,000 cores at the moment across many, many institutions. But there are similar activities going on, and there's a major new initiative around a European open science cloud. So we're very keen to pursue interoperability with these clouds. We and the Australian government is in the research sector are very aware of the fact that Australia is a very small percentage of the international, of the global research community. So we want to be collaborating with people overseas and Nectar wants to make it easy for that to happen, which is essentially what I'm just saying here. And we're doing that through involvement with a number of groups. So there's the OpenStack Scientific Working Group that was mentioned early on. One of our, the people that work with us, Blair, is the co-chair of that. And there's something that new that started at the summit last year, which is the Open Research Cloud Congress, which is aiming to provide an Open Research Cloud declaration, which is basically how are all these research clouds going to interoperate, make it easy for researchers to use resources from multiple clouds, to share applications across multiple clouds. So Wilfred Brimblecombe, who's our operations manager, is co-chairing that group. And as I said, we're working with New Zealanders and in South Africa as well, who are keen to do something similar. So we have strong collaboration to try to make interoperability work for us. Sorry, and I should say the other thing is, which I haven't got a chance to talk too much about, is trying to expand to make use of external resources like public clouds and hybrid clouds. So we've got some pilot projects we're starting to try to do that. So hopefully we can, for example, add a new cell to the Nectar cloud that's actually a managed public cloud resource, but seamlessly looks like just another cell to our users. And that will help us scale up as needed, we think. So that's it from me. There's a lot more information on our website, or come and talk to the many Nectar people at the conference if you want more information. Thank you.
We've got a few minutes for questions, so I will pass the mic around just to make sure the questions get picked up in the video. So any questions for Paul?
Hi, my name is Francisco Brasileiro. I'm a professor at the University of Campina Grande in Brazil. I'm doing a sabbatical at the University of Melbourne, so took the opportunity to come here. In Brazil, I'm involved with a similar project in partnership with the Brazilian NREN to build this federated cloud. In Brazil, we are starting to, we have a proof of concept that is in place, and the NREN team is now working on the business model to put this service operational, and they would certainly be interested in talking about interoperating these initiatives.
Okay. Yep.
So my question is, interoperability is a word with many meanings. When you say interoperability in the Nectar's point of view, what kind of use cases you envision that would be enabled by this kind of interoperation?
So I guess we have two levels of interoperability, one of which we already have, which is interoperating across these multiple organisations in our federation in what is a very seamless way. But in the initial meeting at the Boston Summit about the Open Research Cloud interoperability, there was a lot of discussion about exactly that question. What do we actually mean? What are we actually trying to help at? Everything from, well, really, we just want to be able to say, if we've got people, so the basic thing, for example, Australian researchers got access to the Nectar Cloud, they're collaborating with someone from Brazil or whatever, how does that person from Brazil get access to the cloud so they can use the resources here? So that's fairly straightforward, but it's still not completely straightforward to be able to enable that level of collaboration interoperability. The other one would be, well, Brazil's standing up their own cloud, right? And I've got this collaboration. I want to be able to use the resources for my project, my joint Brazil-Australian project, in both the Nectar Cloud and in the new Brazil project. And I want that to be fairly seamless. I want to run the same applications. You know, that would be fantastic. But as far as I know, we haven't got to that level with any of these international clouds yet. But that should be doable, and that's the main objective of what we're aiming to do.
Thank you.
Any other questions for Paul?
What's the optimal size? If tomorrow the SKA comes calling and say, we want to connect, would you say yes?
I don't think we'd be allowed to say no. Yeah, look, I think that's what we're looking at in the future is if people want to, you know, develop their own clouds with their own resources, you know, they could just do it themselves and it'd be separate, but there's advantages to being part of a national federated cloud, right? So if they wanted to be able to do that, I don't see what the problem. I mean, yes, there are scaling issues, but if people want to put in something huge, I don't think that would be too much of a problem for us. There has been some talk. In fact, I don't know the technical details, but there was a number of talks at Boston around scaling out. You know, if you have a single cell, how big could it actually get before you get scalability issues? But one of the things was, well, you know, if you break it into multiple cells, if you have a lot of cells, actually that's all right. It seems to scale okay. So yeah, there shouldn't be an issue with that.
Any other questions?
I don't have a question, but I have a response to the SKA note, and that is that the South African contingent of the SKA is doing their entire deployment OpenStack based. And part of the argument is if it's a 30-year project, you don't need to go through massive procurements and a refresh every 5 years. You can just scale infrastructure and see it over time. Yeah. That's it.
Yeah, so I should have said I think I mentioned we've been talking to people in South Africa about helping them with the cloud, and that, of course, is one of the drivers, is the SKA collaboration between Australia and South Africa about that infrastructure.
They've all been great questions. Any final questions from anyone? All right, a big final thank you to Paul.
Thanks.